The purpose of this lesson is to teach basic G codes and M codes and how to start up a program. These G codes and M codes are pretty generic, meaning you can use them on multiple machines, such as Haas or Fanuc. To start, you have your G00, your rapid straight line movements. G00 comes in handy when you're trying to move quickly. It saves a lot of time. Your G01 is a controlled straight line movements dictated by a feed rate, which is called out with an F. G01 is primarily used when you're actually milling or drilling, anything of the sorts, into your actual workpiece. You have a G90 and a G91. Your G90 is your absolute coordinate system, and your G91 is your incremental coordinate system. An absolute coordinate system means your zero is stationary. You're moving from one point. So right here in the corner is where the zero is. So if I call up x of 2, I will move over 2 inches in the x. If I call up x of 4, even if I'm right here, starting right here, if I call up x of 4, it'll move me to x of 4 on the blueprint here. Incremental means your zero is not stationary. It's going to be wherever your last point on the blueprint is. So if I start here, and I say x of 2, yes, I'll move over to x of 2 inches. But now if I'm trying to get to x of 4 inches right here, I need to call up x2. So I move over from here 2 inches. 2 plus 2, 4. If I call up an x of 4, thinking I'm going to come here, you're not. You're going to come all the way over here to x of 6. Because 4 plus 2 is 6. Come over here now, you have your G54, which is your work coordinate system. That's you telling the machine where your zero is. You have an M03, which turns on your spindle. With every M03, you have to have an S. It's a spindle speed. You have your G20 and your G21. G20 represents inches. G21 represents metric. You have your M08, which turns on your coolant if your machine has that capability. After that, you have your M06, which is a tool change. With every time you call up an M06, you gotta have a T calling up what tool you want. So if you want tool 1, you go M06, T1. If you want tool 5, you go M06, T5. Then you have a G43, which is your tool height compensation. It's very necessary when programming. It's letting the machine know what tool you have and the height of that tool. With every G43, you use an H to indicate what tool you're using. It's very important that your H and your T value match up. If you have T1 here, you want H1 there. If you have T5 here, you want H5 there. Now go to an example here. Every program begins with your % sign. That's letting the machine know where it's going to start reading. After that, you have your program name, which is an O followed up by a series of digits and then a semicolon. And then a lot of times in programs, you'll see something written in parentheses. The machine doesn't actually read what's within the parentheses. It's mainly for the machine operator or the programmer to put in personal notes. After that, you have your blocks of code. Every line represents a block of code. These N1 values, N2, N3, and N4, those mean nothing other than you're just giving the block of code like a name, theoretically. The machine doesn't actually read the N1 or the N2. So here on N1, I'm doing an M6, which is calling up a tool, and I'm calling up tool number 1. N2, I'm calling up G00, which is a rapid movement. G90, which is my absolute coordinate system. G20, inches. G54 is my work coordinate system. And within that work coordinate system, I'm going to an X value of 0 and a Y value of 0. I'm also turning on my spindle with a spindle speed of 1000. Go down to line N3, you have M08, which is turning on my coolant. Then you go to line N4, which is G43, which is my tool height compensation, with the H value of 1 calling up tool 1. Take note that this H value matches my T value, very important. And then I'm also rapiding down to a Z of 0.1, which is 100 thou. And take note as well that the G00 and the G01 are modal, meaning that you need to call up another G code in their group to cancel them. Thank you.